Okay, everyone can still hear, we're all good?
Yep.
All right. Unit 12 packet questions. Those of you that have been attending the Zoom meetings weekly, I've already gone up to 12.6, I believe. I will double check. Okay. I cannot remember if I did 12.6 with you guys. Can anybody verify if I did 12.6 with you guys? I know I did video notes and homework questions, but did I answer questions with you guys?
I think so, because you were talking about if we did 12.7 already, we could do questions from there.
You just asked us like questions that we might have questions on, and then you put them up for review.
Okay.
Like you explained them later.
Okay.
That's what I saw last week.
Okay. So anybody have questions from worksheet 6 before we move on to worksheet 7?
I have a question.
Worksheet 6 is the compound interest formulas.
I have a question, not about the package, but did you get my unit 8 or like the recovery points?
Yes, I did. I'm sorry I didn't email back. I have everything in a folder for kids who've been turning that work in, and I'll be going through them this week. So if you don't see them in there by Friday, shoot me an email and let me know.
Thank you.
Okay. Unit 6 packet. Jack, you look like you're ready to fall asleep.
No.
Are we boring you?
No.
Okay. All right. So nobody's speaking up, so I'm going to pass on worksheet 6.
Wait, I have
Do you know what
questions.
number 21 is?
What was
Do
that?
you have to worksheet 12.6, number 21?
12.6, number 21. I did that one with the Pequot Native Americans. Is that the one?
Yeah.
I did
Unless
that
it's
one.
probably somewhere in the notes.
I did it not in the notes, but in the, you know how I do the homework question section? I did that one in the homework question section.
Oh, okay. I'll just look at it.
I have questions, Ms. Torres.
Yes.
Number 12, 14, and 16 for 12.6.
12, 14, and 16 can do. Anyone else want to add to that? Okay, so let me write those down. 12.6, that was 12, same again, Eric?
12, 14, and 16.
Okay, I have 12, 14, 16. Any others? None? No. Okay, I'm going to switch screens. Okay, can you guys all see the whiteboard?
Yes.
Yes.
Okay, so this is lesson 12.6. And I am going to start with number 12, which is y equals negative 62.5 ln of 1 minus x over 80, close parentheses. Can you guys verify, is that correct?
Yes.
Okay, it's asking us to solve for x in terms of y. So x is right here. So the first thing I'm going to do is try to get this whole ln by itself. And I would do that by dividing both sides by what number?
You divide by negative 62.5.
Good. Gone. And then that gives me y. I'm just going to put negative y over 62.5. I just moved the negative to the top.
You would
Equals.
you'll put ln e and 1 minus x over 80. And if you put the e on the other side, it turns the negative y over 62.5 into exponent, I think.
Okay, so here's the question I have for you. He is correct. Right here at this point, does the problem have a log? Ln is a log. So does this problem have a log?
Yes.
Yes. So the question is, in order to get rid of the log, there's two things I can do. Either wrap around or drop the log. Both of those get rid of the logs. Is this a drop the log or a wraparound?
Wraparound.
And how can we tell it's a wraparound and not a drop the log?
Because you have a log on one side.
Because I have a log on what?
One side.
Only one side. The other side does not. So you guys are correct. It is a wraparound. So can you guys figure out what I would end up with? E raised to what power?
Negative y over 62.5.
Equals, and now the log is gone, so 1 minus x over 8.
E.
Now I'm trying to get the x by itself, so what would I do first? Multiply by 80 or subtract the 1?
Subtract the 1.
Subtract the 1. And that gives me negative x over 80 equals e to the negative y over 62.5
Minus 1.
minus 1. And the minus 1's not part of the exponent. All right. Any questions before I go any further? No one has a question? All right, if I'm
No,
trying
no,
to, yes. If I'm trying to get x by itself, what would I do?
You would
Multiply both sides
multiply
by 80.
the denominator,
Multiply by, so what would I multiply by?
80.
80. Are you guys okay if I do negative 80 to get rid
Yes.
of the negative
That's
sign?
what you're supposed to do.
Okay. X equals negative 80 parentheses e to the negative y over 62.5 minus 1. And there's your answer. If you wanted to, you could distribute negative 80 e to the negative y over 62.5 plus 80. Either answer, you do not have to write both of them. Either one is correct. Does anybody know how they write it on the packet answer key? What lesson is this, 12.6? The packet writes it this way on the answer key.
They write it the first one, yeah.
Yeah, they did not distribute. Okay, any questions on number 12? No questions? All right, I am going to erase it all. Does anybody want a little more time to write it down? No one's stopping me, so I'm going to clear. Okay, so from lesson 12.6, I'm going to go over number 14, which is a similar type of problem. Not the work is not exactly the same, but it's a solve for x in terms of y. All right, what's the first thing I would do to get this whole log piece up? Actually, let's see, I'm gonna redo this. Okay, to get this log piece by itself, what would I do first?
Multiply
Multiply
1.5.
1.5 by 1.5.
Gone. So I have 1.5y equals log of x minus 11.8. Now
You
the x is attached to the log, but not the 11.8. So how would I get rid of that next?
add
11.8.
And these are not like terms. So I'm going to write it as 1.5y plus 11.8 equals log of x. Okay, does this problem have a log in it?
Yeah.
So I could either drop the log or wrap around. Both of those will get rid of the log. What is this? Drop the log or wrap around?
Wraparound.
Wraparound.
And why is it wrap around?
Because there's log only on one side.
Only a log on one side. What's the base that I don't see? E or 10?
10, I believe.
10, and I wrap it around to all of this, and it'll equal the x. So that would look like 10 raised to the 1.5y plus 11.8, all of that is the power, equals x. Make sense?
Yes.
Questions on that one?
No question.
No questions? Would anybody like it up a little bit longer? Okay, I am clearing. And lastly is number 16. And that reads, if $10,000 is invested at 7%, compounded continuously, how much is the investment worth at the end of 25 years? Okay, key word there was compound continuously. Is compounded continuously the longer formula? I'll write this down. And I will tell you right now, like if we were in regular class session and we were taking a regular test and a regular final, these two formulas would be given to you. You wouldn't have to memorize them. You would have to know what the letters stand for, and you would need to know when to use which one, but memorizing them you would not have to do. Okay, so if it's compounded continuously, which one am I going to use?
The one on the right.
This one here, the PERT. I use the one on the left when it's compounded quarterly or monthly or 5 times a year, whatever it may be. Compounded continuously is the PERT formula. Okay, A is the amount after so much time, and that's what we're looking for. It asks how much do we have after 25 years. P is the initial amount. How much, what is the initial amount? The initial amount taken to the bank. It says
10,000.
$10,000 is invested. R is the rate. What's the rate as a decimal?
0.07.
And then T is how long you're leaving it in the bank, and how long are we leaving it in the bank?
25 years.
25 years. So we have A equals 10,000. E is a number in your calculator, raised to the 0.07 times 25. And you would need a scientific calculator to work this out. I'm going to go grab mine really quick. All right, hopefully you have yours as well. You don't have to multiply these two together right now. You can plug it all in at one time. Would you guys like me to show you? Actually, you can't see the calculator, so I'm just gonna plug it in right now. 0.07 times 25 is 1.75. And do you guys know how to type that in your calculator?
Yes.
Okay, so you type in 10,000. Second LN would give you your E key, and it's raised to the 1.75, and that gives me 57546 and 3 cents. So we'd have $57,000, $57,546.03. Questions on that one?
No.
Does anybody have any questions on how to plug it in? I can flip the screen back up and show you in the calculator.
No, it's okay.
We're good? Okay. Any other questions from lesson 12.6 before we move on to 12.7? None? We're good?
We're good.
Okay. Questions from 12.7. 12.7 is the last worksheet, I believe.
Number 9.
Number 9. Any others?
You go over 6.
6. Who asked for 6?
Yeah. Garen.
Garen. I don't mind doing
Yeah.
6. Did I do that one in the video homework questions? I did do it in the video
Oh,
homework.
I didn't check.
Okay. I can still do it if you'd like, but it is there, just so you know.
Okay.
Any others? Would you guys like me to tell you the ones I did in the video homework questions?
It was
Yes,
4,
please.
5, 6, and 10.
I did, on my paper, oh, you know what? I have it right here. I did 4, 5, 6, and 10. 4, 5, 6, and 10.
Can you do 1?
I can do 1.
Didn't you do it in notes?
I was just about to say that I think I did 1 and 2 in notes.
Oh,
Would you still like me to walk you through it, or you think you're good?
no, if you did it in notes, then I'll
Okay.
listen.
All right. Any others? Number 3. I don't know if I did number 3 in notes.
I think you started it.
Okay.
Have you done
So
14?
Which one?
14?
Is there a number 14?
No.
No, no number 14?
For 12.6 or 12?
Yeah, there's
Oh,
no
so-
number 14 on worksheet. It goes up to number 10. Worksheet 7.
Oh, I think she's on 12.6, right?
I'm going to erase this because we're now on 7. So can I erase
Okay.
this? Okay. So we're on 12.7. The ones that have come up so far is 9 and maybe 6. Any others?
7.
7?
Yeah.
Okay.
Actually, you told us to skip that one.
Did I?
Like on the little
Assignment sheet?
schedule. Yeah. Yeah, 7 and 10.
Oh, it says 1 through 6, 8, and 9.
That's okay. I did all of them anyways.
8 and 9. So you didn't even have to do number 10, and I did it for you anyway. Huh. Thank you, whoever caught that. Okay, so I have number 9. So no number 7, since we didn't have to do it. So starting off with number 6, did we still want to do number 6? Yes or no, because it is on the video homework question notes.
Yeah.
You'd like to see it?
Yeah.
Okay. 6 is a good one anyway. It's the one with the anesthesiologist. Do you guys know what an anesthesiologist is?
They
Yes.
are given anesthesia during surgery in an OR.
They do what?
They provide the anesthesia during surgery in an OR.
And maintain it.
And maintain it. Do they just inject you and walk away?
No, they
No. They stay there to make sure that you stay under during the surgery. Okay.
Yeah.
So during surgery, if you have the packet out, it says during surgery, a patient's circulatory system requires at least 50 milligrams of anesthetic. So you need 50 milligrams in order to continue with the surgery. The amount of anesthetic present T hours after 80 milligrams of anesthetic is administered. So original amount given is 80. And I'm going to erase that because it gives that to you in the formula. Is this formula here. A of T equals 80 parentheses 0.727 raised to the T power. Is this a growth rate or a decay? Is it an increase or decrease? Can anybody tell by looking at 0.727?
Formula.
It's a decay. Why is it a decay? Because
Because
this
it's less
value
than 1.
here is less than 1. Does it make sense that if they inject you with an anesthetic, that it's not growing in your body, it is eventually decaying? You're ending up with less in your system. Okay, part A, how much of the anesthetic is present if the patient's circulatory, in the patient's circulatory system 30 minutes after the anesthetic is administered? T is the time. In hours is what the paperwork says. So what I type in, when I plug it in for part A, 30 minutes later, how much is in their system? Would I plug in 30 for T or 0.5?
0.5.
0.5, and you just plug it in. A of T equals 80 times 0.727 raised to the, not 30th power, that's just what I told you not to do, raised to the what?
0.5.
0.5. And you would just plug that in your calculator. So I'm going to plug it in now. 80 close open parentheses 0.727 close parentheses exponent key 0.5 and equals, and I end up with 68.211. Did you guys end up with that? 68.211. And you could even put 0.5 right there. It's not necessary, but right here. So this is just saying when you have at half an hour, there's this much left in your circulatory system. Is there enough in your system to continue with the surgery? You need 50. Is there enough in your system to continue with the surgery?
Yes.
Yes. Okay, part B, how long to the nearest minute can the operation last if the patient does not receive an additional dosage of anesthetic? So let's pretend the anesthesiologist says, I'm only giving 1 and that's it. How long to the nearest minute does can the surgery last? What do I do? How much does a person need in their system for the surgery to continue?
50.
So I want to know, how long does it take for us to end up with 50? Where do I put the 50? In for time or in for the A of T?
An A of T.
Yeah. How long does it take for us to end up with 50 milligrams? If 80 milligrams was administered and the decay rate is 0.727, and we're looking for how long does it take? What would I divide both sides by? What is it?
Was it 50 or 80?
80, because I'm trying to get the variable by itself. So what's 50 divided by 80? Anybody have it? 50 divided by 80?
Was it 0.625?
0.625 equals 0.727 raised to the T power. Okay, is there a logarithm in this problem?
No.
No. So I'm not going to drop the log or rewrite it like a wraparound. But where is my variable? Is it a base or is it an exponent?
Exponent.
Exponent.
Okay. Now I've given you tools in notes on how to get it out of the exponent. I'm going to do it the way I've always done it in notes so I don't confuse anybody. There is more than one way to do this. The way I've done it in notes is taking log of both sides. And in notes, why do I do this? What's the whole reason I do this? Is so that I can do what with that exponent? Does anybody remember? It's a log law. I don't want it
You
there as
drop
an
it in front.
Put it in
bring
the
it
front.
to the front. That's the whole reason I take the log of both sides, is so I can use my log law number 3 and bring it to the front. Right, now I'm trying to get T by itself. What would I divide both sides by?
Log 0.727.
And that's what you're going to plug into your calculator. Log of 0.625, make sure you close your parentheses, divide log 0.727 equals, and I think I did something wrong because it didn't come out right. I'm going to type it in again. Those of you that typed it in, it should be 1 point something. I'm going to type mine in again. Oh, I see what I did. I used ln instead of log. So I'm starting over. Log of 0.625, close parentheses, divide log 0.727. All right, what do you guys get? 1.4.
474.
Got it? So a little less than an hour and a half. So a little less than an hour and a half, they would have to have the surgery done. If they took an hour and a half or more, the patient would need more anesthetics. Does that make sense?
Yes.
Questions on A or B? Are we safe to erase?
Uh,
Sorry. 12.7, this was number what? 6, and I am part what? C? Okay, we're using the same formula. A of t equals, was it 80? 0.727 raised to the t. Okay, and part C is asking us, to the nearest minute, what is the half-life of this anesthetic? We want to know how long it will take for us to end up with half of what we started with. So what will A of t equal?
40.
Right here, I'm going to put a 40. Do you guys understand why? Because I'm looking for the amount of time it takes for us to end up with half of what we started with. We started with 80, so how long does it take for us to end up with half? Does that make sense?
Yeah.
Yeah? Okay. What am I going to divide both sides by?
By 80.
80. So that gives me 0.5 or 1/2, 0.727 raised to the t power. Okay. Does it make sense that we end up with half if I'm looking for half-life? How long does it take for us to end up with a half-life? Okay. What do I do to both sides so I can bring the power down? I can't do it right now. What do I have to do to both sides first? Take what of
Well,
both sides?
the log.
Take the log. Log of 0.5 equals log of 0.727 raised to the t. And why do we do that?
So we can get the t by itself.
So we can bring the t to the front to get it by itself. All right, now I'm trying to get t by itself. What would I divide both sides by?
Log 0.727.
Log of 0.727. And I don't think I did this part with you in the video homework question, so I'm going to type it in now. Log of 0.5, close parentheses, divide by log of 0.727 equals, I got 2.174, if you guys can verify that. $1.474, nope. What did I say I had? 2.174.
Yes.
So is the half-life a little more than 2 hours or a little less than 2 hours?
A little bit more than 2 hours.
A little more than 2 hours. Do you guys agree? Is there enough? Never mind. I'll ask it on the next one. Okay. So all right, so time is 2.174 hours. Questions? So it takes 2.174 hours for us to end up with half of what we started with. Okay, this was part C. Part D is asking, pharmacists and anesthesiologists multiply a medication's half-life by 5 to estimate when a medication is cleared from a patient's bloodstream. To the nearest minute, how long does it take a patient to eliminate all the anesthetic? Have you guys ever seen like a medication bottle, like do not operate heavy machinery while taking this medication? Or the doctor will say you cannot drive, you'll need someone to drive you home and you cannot drive for 5 hours or something along those lines. That's because they still have some of the medication in their system. So in this particular problem, it says they multiply 5 times the half-life to figure out how long it takes to eliminate all of the medication from your body. So to the nearest minute, how long does it take a patient to eliminate all of the anesthetic? 5 times what? What is the half-life we just got?
2.174.
2.174, and that's what you're going to multiply. So multiply that now. You get 10.870. So it takes a little more than 10.5 hours for your body to eliminate all of that anesthetic. Never mind. Any questions?
I thought it was 10.87.
It is 10.87. And that's shame on me. And I have it on my calculator. I don't know. Did I say 87 and just wrote it that way?
Yeah.
Okay, sorry. Thank you. All right, questions on number 6.
Weren't you supposed to convert into minutes though?
To the nearest minute, that's this part here. You can convert it to minutes, it's not necessary. Would you like me to convert it to?
It's not very hard to convert it. All you gotta do is convert the decimal into minutes.
Yes, and you can. I don't know if, let me see how the worksheet writes it. Yes, they did. They did both. They have this one and 10 hours and 52 minutes. Okay, are we good?
Mhm.
Okay. Anybody need this up a little longer or am I safe to clear? Okay,
Good.
clearing. So this is 12.7 and I am on number 9.
Yes.
Number 8 real quick.
Uh-huh.
Could you do
What-
number 8 real quick?
Do number 8 really quick? Yes.
Yeah.
Okay. A satellite has power supply whose output in watts is given by 50 times E raised to the negative 0.004 T, where T is time in days. All right. How much power will there be at the end of 500 days? So what do I plug in the 500 for? I'm going to repeat it. A satellite has power supply whose output in watts, so this is the output, is given by this formula where T is time in days. How much power will there be at the end of 500 days? Where will I be plugging in the 500?
For T.
For T. So W of 500. If you don't like writing it, you can just put Y equals. It doesn't matter. 50 times e raised to the negative 0.004 times 500. I'm going to multiply that exponent out first. And I get -2. Did anybody else do that? Did you get -2? Can anybody verify that?
Mhm.
I just wrote it down wrong and didn't put the 500 on the t and the exponent, and I was really confused.
Okay, does it make sense now?
Now that I have put the t at the top, yeah.
Okay, well, I'm ready here. I'm gonna go ahead and plug it in.
Yeah.
So I just type in 50 second ln to get my e key, and then -2 equals 6.767 watts. Is that right? Okay, makes sense.
Mhm.
All right, any others in this section, or any others here before I erase? Okay, I'm erasing unless you're gonna stop me. Okay, lesson 12.7, number 9. A radioactive substance decay with time. Radioactive substances decay with time. Starting with in grams, the number of Y grams present T years later is given by this equation. Okay, N is this is always the initial amount, whether they call it N or P or A naught, whatever that is, that's always the initial amount. This is always the amount after time. T is time and K is your growth or decay rate. Okay, so in 10 years, the mass of a sample element has decayed to 100 grams. The constant K for this element is a long decimal. Find the mass of the original sample. So find the mass of the original sample, and I'm gonna undo that. The original would be E. Okay, so I'm gonna read it again. The number of Y grams present T years later is given by this equation. In 10 years, so T is 10. In 10 years, the sample element has decayed to 100 grams. Where does that 100 go? The Y or the N or the K?
Y.
We're looking for how much was present initially if after 10 years there's 100 grams left, and the K is given as negative 0.06931. So we're ready to plug in. Y equals N, we don't know, but we do know Y. What is Y? What is Y?
100. 100.
100 equals, we're looking for N, E raised to the negative 0.06931 times T, and T is 10 years. What do you get when you multiply that decimal by 10? What is multiplying by 10 moves your decimal one place to the right? So negative 0.6931. Does that make sense? And what did I forget to write? What am
E.
I missing? The what?
The E.
The E. E raised to that power. All right. Anybody know what to do? Is my variable a base or an exponent? The variable I'm looking for is N. Is it a base or an exponent?
Base.
It is a base, so I don't have to do log of both sides. Anybody know what this is right here?
That's the exponent. You can divide by n, I believe. No?
I see, that's what's a little confusing. Do I divide by n? N is what I'm looking for. So what I'm going to divide by is whatever this decimal is right here. I'm going to erase that squiggly line, but that is what I'm going to divide by. How do I find what that squiggly line, what that number is? I plug this into my what?
Calculator.
Into the calculator. Okay, so if you have your calculator, you would do second ln and then negative 0.6931, and that gives me 0.5002 ... I'm just going to leave that number in my calculator so that, because I don't ever want to round when it's a long number, I'm just going to ... so I don't have to write everything. All right, what am I going to divide both sides by?
0.5002.
Okay, so that's gone. N equals, and I type in my calculator, 100 divided by second answer, and I get 199.991. Make sense?
Mhm.
So
Yes.
if I started with this amount, then after 10 years, I would be left with 100 grams, which makes sense because it's decaying. So I end up with less of what I started with. What would you say about this? What is this number really close to, our answer? The nearest 100. It's really close to 200. And is 100 half of 200?
Yes.
So you could say the half-life is really close to 10 years, right? After 10 years, you end up with about half of what you started with. Make sense?
Yeah.
All right, any other questions from 12.7? Okay, after we end here today, I am going to do recordings for the review worksheets and put those up. I haven't done it yet, but I will be doing it right after we're done. Do any of you guys have questions from the review, or do you want me to wait until I post the video for the questions?
Wait.
I
What
could
was that?
wait.
I can
Okay,
wait a little bit.
wait a little bit. Okay, are we all there?
Mm-hmm.
Okay, any other questions?
Nope.
Nope. We're good and ready to say goodbye?
You said you're gonna do the review worksheet on Thursday?
Yes, I will answer questions. I'll post the
Okay.
video today so you guys can watch it today, tomorrow, and then Thursday's Zoom meeting, I will go over.
So wait, so the homework questions are on your the YouTube channel, right?
Yes,
Or are they on your website?
they're both.
Okay.
Yeah.
Mhm.
Okay. Well, I love you guys. Miss you guys.
I miss you too, Miss Torres. I miss being in that classroom and falling asleep.
Just being in class.
Well, I do have to say, those of you who are going to be here next year, if we do not return this year, I expect you to come by and say hi, since we're not getting an actual goodbye. And those of you that are gone, when you come back and visit, you better come by and say hi.
Wait, so I didn't understand what the board was meaning in their email. Like they were like not like, does that mean like we're going to have like a small portion where we go back to school, or they're going to cancel for the rest of the year?
That's our anticipation. As of right now, we're anticipating, what is it, about 2
Lower
weeks?
classroom. Yeah, lower
2 weeks is
classroom
the
would
last
come
of the
back if
school year,
they
right?
did
No?
come back.
What was that, Eric?
What?
Lower
I
classmen
thought they're going to
would
open
be
for a
the
small period at the end of the year if conditions probably got better.
What would be the point of it? Is that what you're asking?
I'm saying that like I thought the board meant that they're gonna open up the schools for a little bit of the remainder of the year if the conditions got better.
Yes, and if it doesn't, then we will not be coming back this year.
I just don't understand why CUSD is the only people still trying to keep school going.
Yeah.
Because everyone else,
weird.
everyone else is shut down, and like if you think about it, like if one teacher, like one kid, like does have coronavirus, then you go back to school, then you can infect the whole classroom with it. I mean, the whole school if that does
That
happen.
is true. Is that your dad, Eric?
Yes, this is my
Hello. Okay. It's not all schools. Fresno's, I know, has. Kerman has not. Kerman hasn't even extended it. Kerman Unified has not extended it as far as we have. Fresno has, I think maybe LA has. I'm not sure about LA. I think they're just trying, because the state hasn't said you guys cannot go back. They're trying and hoping that things get better, so that we have a little bit of time to regroup and, okay, I turned this in. Did you ever get it? No, I didn't. Okay, here it is. Whatever it may be. But if we can't, I mean, if things don't get better, Eric, they're not going to make us come back.
Yeah, I know that.
So
I did not see the year 2020 ending like this for seniors.
I know. I feel bad for the seniors. I really do.
Me too.
Yeah.
Yeah, we don't even get like a graduation ceremony, right?
I know, it
It's
sucks.
not even in person, so I'll probably online.
I didn't go to prom last year, so I didn't even get to like go to prom.
So you're like, oh, I'll go my senior year, and then,
I
No,
was gonna go with Andrea.
aw.
right there.
We went to Sadie's and formal together, and
Right there.
Yeah.
The black board that you just uncovered. Oh.
Is there any way
There it is.
notes of the other recordings that you did on Zoom?
What was that, Andrea?
Is there any other way for us to access the other recordings that you did on Zoom?
This is our third Zoom meeting, I believe, right? Fourth. The first one I didn't record because I didn't know I could.
Yeah.
Second one I recorded and posted already. Third one I recorded but couldn't, like, it didn't work at the end. So I'm hoping at the end of this one I'm going to be able to post it at the end.
Okay, and where would you be posting it